Hey, hi guys. Good morning.
Go.
Let me start sharing my screen. Hey, hi, good morning. Yeah, so far we discussed about just the Hive overview and Hive architecture. We talked about Hive architecture and the flow, how that happens between your Hive, Hadoop, and HDFS, and also with the metastore. And yesterday we have talked about the arguments, Hive session arguments. These are the Hive session arguments. While logging into session, so what are the various arguments that you can pass? Okay. And so Hive CLI commands, once you are into session, what are the commands that you can run? And what are the data types that Hive supports? And some of the complex data types. And we have seen the database commands: create database, show database, use database, describe, alter, and drop. We have discussed about all these things. And delimiters in tables, an example table creation, and this sample data. And also we talked about the basic SQLs like, so let's start from and using the where classes and join syntax till there. Okay. So let's continue with the subsequent topics. So today mainly so first let me continue with the table types. And next, metastore types. So here, local metastore, embedded metastore, I can say. Embedded metastore and local metastore and remote metastore. Okay, so let me give you some brief information about these metastores also, and I will show you the data as well in those metastores. Okay, so I will update the text for this while taking the session itself. So in Hive, in Hive and Impala, in both the places, so we have table types. So we have mainly two different types of tables. So also we have the third one got recently introduced. That is for temporary purpose. I mean temporary tables, which will be active only during the session. Okay. So if we keep that temporary tables aside, so mainly you can think of two types of tables. Okay. You always, once after this session, you always get a question that, so which one to go with what time? Like, so based on a scenario, so whether I should select a managed table or external table. Okay. You should be able to answer this question. Otherwise, you will be in dilemma to choose which tables you should pick up. So, so managed tables. So mainly the two different tables are like managed table or internal table. Managed or internal table. Okay. And second type is external table. So here, by the name itself, managed tables will be managed by your Hive. What does meaning of management here? Okay, first let me tell you this. So Hive table is, I will make one formula here, a statement here. Let me know whether you guys agree it or not. Hive table equal to data in HDFS metadata in metastore RDBMS. Okay. So everybody agrees on this. Okay, still here. Okay. Now the basic one-line difference between these two is managed tables means when you drop a managed table, when you want to delete that managed table, both the HDFS directory and as well as the metadata in RDBMS will get removed. So if you delete or drop a table, both are same in Hive. We don't have delete statement. We just have the drop statement. And if you drop a table in Hive, if it is managed type, it deletes both the data and as well as metadata. This will get deleted and this will also get deleted. Okay. Whereas in case of external tables, this will not deleted. This gets deleted. In case of external tables. That's the only difference. And by default, if you don't specify the table type, it will become managed table. And if you want to specify the data type of a table, then it will become an external table. Okay.
You are a little not clear, Siva.
You're still not clear?
One quick thing.
See, let me clarify this. So Hive table is nothing but data in HDFS and metadata in RDBMS. Do you agree to this statement?
Yeah, that I agree. Yes.
So managed table means if you drop this table, both data and metadata gets deleted. Is that clear?
Yep, that is clear.
And external table type means only the table definition will get deleted, but the actual data behind the scenes will not be deleted.
So then we have to go manually into HDFS and delete that?
Yes.
And why is it like that? So what is the use of external table? You know,
I'm
what do you?
coming there.
Okay. Okay.
I will
I don't think it stores the file in the warehouse, right?
The basic questions I can expect from you. I will always try to answer those questions. Okay.
Quickly, before you move forward quickly, Siva, one more thing. Data in HDFS. If there is already data in HDFS, that HDFS will have table definitions. Then why do we need a metadata? That is not clear.
See, will HDFS store tables?
It will store something, right? It will store in a form of file.
It
Right,
will
which-
store files. In files, do you specify the column names and their data types? Can you query on a file?
No.
Metadata will never be stored in HDFS.
So
Especially in a file, you can't store that also.
it will be just like a raw data will be
Yep.
stored in a format.
Yes.
So, but whether which column that data belongs to, that all definition will be in the
Yep.
metadata.
In metadata.
Okay. Okay. Since it's a file base,
Yep.
you need a. Okay.
This is a file based.
Okay.
Okay. So now it's clear, right? At least what is what. Why we'll discuss now.
Yeah.
Okay. So managed tables are the default type in Hive. If you just specify the create table statement, so create table statement, create table name, so it will create the managed table. Okay. And whereas if we create a external table, if we need to create an external table, the syntax is similar, like, so create external table T3 and specify your column names A equal to string or something. So you will find an extra keyword external. Okay. So in the early releases of Hive, there was one more difference, which is no longer valid these days. So for your information, I will tell that difference also, but that difference is no longer existing. Okay. So for managed tables, we were not giving the location class. HDFS location path we are not providing for managed tables in the in some releases back. Okay, in a few releases back of Hive. These days, yes, you can provide the location class to both managed and external as well. So in the early releases of Hive, so location was mandatory for external tables. So if you are using external table T3 and if you don't provide the location, then it was throwing the error message, syntax error message that for external tables, it is expecting the location. And for managed tables, it was optional, and we were not giving the location class for managed tables. But in the latest releases, it seemed like the location can be used or can be removed. In both the tables, it's optional. So now I have a question for you. If we don't specify the location, what is the default location where it stores the tables directories in HDFS? If you remember it.
With the warehouse location, user warehouse.
User Hive warehouse. This is the directory. And if I create a T2 table, I will have a T2 directory inside this. Let's say I'm creating this T2 inside another DB, which is test_DB or test_DB. Then I will have one more directory, test_DB.db, which is the directory. Inside that, for every table, you will have another subdirectory. So now here T2 is managed under the same path if I use this above syntax, and T3 will become external. So if my table is managed, Hive will have complete rights on it, complete accesses. It can delete both the data and metadata, table definition also. So if it is an external table, so the name itself says that the data is external to Hive. It is not, data is not being managed by Hive. Data is external. One single example that will answer your question why we need external tables. In case of integration with one basic fundamental reason I can tell you. Okay. So suppose you have an HDFS directory. Okay. So that is a file of a HDFS directory which contains the input data for your table, but the same data being used in multiple places. You are using the same data for some kind of MapReduce. You are running some kind of MapReduce jobs on that for some other purpose, and you are running some kind of pig scripts for some other purpose, and you are running some kind of Hive queries as well on the same data. Okay, so the same data you referred in HDFS, in Hive, and in Pig, and in MapReduce. Now, if you drop that table in Hive, it will delete the data also if in case the table is managed, which will affect other ecosystem tools as well. So these dependencies are in a dilemma now. So this is one scenario, and second, one more real-time scenario is, in general, we'll see HBase will create a table in HBase, we'll refer that table in Hive. Using HBase storage handler, so we have seen even in Pig how to read a HBase table. At least I have shown you the syntax there. Okay, so once after you complete the HBase sessions, you can take this, take those examples. Okay, so if you can create a table in HBase using the HBase storage handler, you can access that data in Hive. In that case, the data is external to Hive. Data is not present in Hive. Data is present in HBase. HBase in the sense, of course, in the backend, it's also a HDFS only, but a different file formats in HDFS. Okay. So now in HBase storage, so the data is handled by or owned by HBase, and you are using only Hive to view that data through Hive layer. Whenever you want that in Hive, if you want to run basics in SQL queries, you can run that, you can access them through Hive. So in this scenario, if it is a managed, if you delete your table definition in Hive, it should delete the HBase data also, which is against the purpose of you maintaining it in HBase and viewing through Hive. So in this scenario, it's always mandatory to go with external. First of all, it will not even allow external table. You should go with external tables. Okay. So why do we need these two integrations? We'll discuss during our HBase sessions. So the basic difference is that managed means if you delete it, both data and metadata gets deleted. And external means only the metadata gets deleted. The table definition will get deleted, but the underlying data will be still present. And in that case, later in some point of time, so after 1 month or so, again, if you wanted to use that table, it's just a matter of creation of a table, just creation of table, table statement, that's it. If you submit a create table statement and pointing to this location, then again you can refer to this table data. Whereas in case of managed, if you drop a table by mistake, suddenly, that's it. You are gone, you lost your data. You cannot recover unless until you have any trash enabled on your cluster and admins, if they can recover it. So that is blah, blah, blah. So because of that reason, unless until you use frequent drop statements in your application programming, and you actually need the dropping of the data also, then only you should go with managed tables. In case of external tables, if you drop anything and your purpose is not dropping the table, and it also dropping not just the dropping of metadata, it also for deleting the data, then you should always go with the external managed. If you want to keep the data as it is, but the table definition needs to be deleted, then prefer externals.
Siva, without metadata, what is the use of that data?
See, you can use that. See, that is a file. You can use that file in Pig. You can use that in MapReduce. Suppose if that table is present in HBase, if you can't access it through Hive, we can access it through HBase.
But how would the HBase know that which is the column, which is the row?
HBase is a database. No worry about it.
Okay, HBase will know. But what about the other, like Pig and?
How are you loading into Pig till now? When Hive was not there? Same fashion.
Oh yeah. So it will be just a file. Okay.
Yep, it will be just a file.
Shiva,
Yes, Satish.
the same file could be used by other table as well, right?
The same file could be used by other tools.
Other table or other tools.
Other table or tools, yes. Okay, but real time don't do that. Okay. Okay. So can external table be changed to manage later? No. Once it's created, that's it. We can't do that.
So Shiva, in that case, we can never get rid of the data. Suppose in longer run, after a few years, we feel that this data is just occupying the space and we
Yeah,
want to.
why don't you do that? You have Hadoop FS minus RM.
Oh, yeah. So that's alternate. Okay.
Yeah. So drop your table and delete your directory. So whenever you drop a table, immediately after that, run this action as well if you really don't want that data also. When by mistake you created it as external a year back, and now these days you no longer need that external feature. You want always this to be managed, then use the drop statement here, and immediately after that use the drop table name, and immediately after that provide the path of the table with HDFS.
Okay.
Siva, one more thing, Siva. If we go to production, we would not need there won't be much scenarios to drop this table, right?
Yes.
Once you go to production, like in development, yes.
There will be scenarios. I will explain those things. Like, see, let's say if you are receiving a country data, if you are receiving a country data or state data, which is almost 90% static. Okay, so 90% of the records are static, only 10% of the records are dynamic. And whenever you receive a data of those 10 records being changed every day, you want to do a full refresh of the data. Then in that case, so we'll discuss about the partitions next, the next part. So we'll drop a partition. If it is a managed table or if it an external tables types, the same features will hold good for partitions as well, not just the drop of a table. Partitioning, anyway, we'll discuss that later. So if you drop a partition, in case of external, the data will not be dropped. Only that link will be dropped. And if it is a managed table, the partition will get dropped completely. And if you load a fresh copy of data, then that will only be present in that partition. So if you are dealing about the dropping of tables, always go with the managed tables. So unless until there is something specific reason, don't go with external tables, especially when you are dealing with the dropping of partitions. The reason is it will not drop the underlying partition directory, and you feel that the partition is dropped, and you reload one more partition into that, then what will happen is it will get appended, keep on appending. That happened in our projects also. Okay. Anyway, I will reiterate the same stuff. So when we discuss the partitions again. So a good use case for external table could be eliminates the redundancy of data storage. Yes. And a good use case you will find to use external table type Cs when you have the data in HBase and want to access in Hive. Okay.
Shiva, one more question. So similar way, we can also not change managed to external if later on we
And
decide
also,
that
what
this
is it?
data,
Yes, we can't
similar
change the
way we
managed to
cannot,
external.
sorry.
Yeah, we can't
Yeah,
change managed to external and external to managed. Both the ways are not possible.
okay. So there is no workaround for that. Like
There
if
is
I
no
want
workaround also.
only to drop the data now.
How will we?
So there is no workaround like you told me about the Hadoop FS remove.
Mm-hmm.
So if later on I decide that this data is really important and I want to
You can't do
nobody
that.
to drop
There
it.
is no workaround for that.
Okay.
There is no workaround. So once you drop a managed table, even by mistake, the data is lost. That's it.
No, but before dropping the managed data, if management make decision that this data is important and they wish it was external data so that nobody can touch
There
it.
is no way that you have to make a one another copy of the same table with external type. Okay. So keep that new directory, whatever you copied, and remove the old directory. That's it.
Okay.
Some or the other way, if someone deletes the managed table, it gets deleted. That's it. No other workaround.
Okay. Thank
Okay.
you.
Yep. Next, let me move on with next topics. So default type, external tables, and temporary tables are just active for that session. Okay. So once you come out of the Hive shell, they will be lost. So tables data is managed by Hive by moving data into its warehouse directory if you don't provide the location. If you provide the location path, then it will store in that. Okay. In external tables, these tables are not managed or owned by Hive, and tables data will not be copied into Hive warehouse directory but maintained at external location. So this last line is no longer valid. This is no longer a mandatory rule these days. Okay. Maintaining at external location only, not in the warehouse directory. Okay, you can create either in the user Hive warehouse directory or even at external directories. Then also you can make it as external. Okay. So these tables are dropped, only the schema from the metastore will be deleted. So provides convenience to share the tables data with other tools like Pig and HBase. So location class is mandatory to create an external table. Otherwise, table will be managed by Hive only, even if we create it with external keyword. So this statement, excuse me for this statement is no longer holds good. Okay. So I will try to strike off this. If there are any guys who learned it some time back, so for their purpose, I will keep that, but I will strike off that statement. Temporary tables, by name itself, these are temporary and available till end of current session only. So useful in case of creation of intermediate tables to copy data records from one table to another, but can be deleted after our copy operation. Okay. So for creation of temporary tables, in place of external, specify temporary. That's it. Okay. Now, let's see. I will give basic assignments on them, like creation of a managed table, creation of an external table. Okay. So take some users records. So let me create this assignment also for you. Hive commands and functions. So table commands. Post Hive storage formats. Yep. Take this sample records. Okay. So mimic this data. So first step is your input data, collect input data from this URL. Okay. So make it around that 100 records or so. Okay. Now create an external table. Okay. Side. Hey, sorry, there was a network problem. Okay. So I want you to create an external table, and on top of this data, so this data is having first name, last name, company name, address, country, city, state, post, phone numbers, email, web. Okay. And so create an external table, one external table using the above data. Okay. And create an external table and drop and observe. Okay, so create an external table using the above data with external location, not the default warehouse location, meaning use the location class. Okay, and drop and observe the data relation. Okay, and create an managed table on the same thing. Create a managed table, same stuff. So using the above data with external location. Okay, so with external location and without the location as well. 5, 6. So we'll discuss all these. If you face any issues, we'll discuss on Monday. With above data, using the above data with default warehouse location. So don't use the location class. Default warehouse locate and drop and observe the data deletion. Okay, tell me whether whatever the statements that we discussed are holds good or not. This is still here, and create an external table, create a temporary table, and just create temporary table and exit from your shell and recheck and check. Exit your shell, re-log in and check whether your temporary table is still present or not. Okay, next 8. Before dropping this table, so third table or fourth table, in any of those tables. So I need the count by from table created in step 3. Okay, so I need count by state. I want to know, so how many users are there for each state. Okay, and display me need count by state and only the top 10 results in the descending order. Need count by state, only the top 10 results in descending order. Okay. So these are the assignments so far. Okay. So yeah, if I keep moving on with the topics, I will keep on adding to this list. Okay. So now let's discuss about the metastore types. So here there is nothing to do with developers in real time. So once it is metastore is decided, this topic is this slide is mainly for administrators. Okay, so this topic comes at the time of initial setup of your Hive. Default metastore type in Hive. Okay. So embedded metastore means by default when you get your Hive downloaded from your Apache parcels, and if you just extract and start using this, and if you don't install any other external RDBMS, MySQL or Postgres, and if you don't configure that MySQL or Postgres to Hive in order to store the metadata, so by default Hive uses the Derby database, which is also one type of an RDBMS. It stores its data in a files. It's a files kind of system. Derby database is the default RDBMS that ships with every Hive installation. Okay. let me show that since this is purely an admin stuff, you need to deal with the configurations here. So configurations will be part of your etc hive conf folders, and this is your hive site.xml file. So here I have javax.jdo.option.connection driver name. So in place of this, I will be having, in place of this value, so I will be having the DB database related values. Okay. So let me show that the help of, I have an extended article on this. Hive installation. So metastore configuration. So embedded metastore, local metastore. Yep. This diagram might be more helpful, I think. Yeah. In case of Derby, you will have this javax.jdo.option.connection URL this way. So JDBC colon Derby colon database name, what is the location where it is gets stored, and connection driver name apache.derby.jdbc.embedded driver. Okay, so these two properties, if you have in your connection driver name as Derby, that means that is the default Derby database it is using. So we have lots and lots of limitations with Derby database. So one simple limitation is that it can't support the multi-user login. Already one user is logged into Hive shell, pointing to that Derby driver and Derby database. So one more user cannot log into that. So that is the reason you never see a Derby database being used as the metastore in Hive in real time. You will never see that. Okay. The next one is local metastore. I don't have the rights to copy or something. Let me log into this. Okay. So someone asked me to differentiate between the metastores. That's why I'm taking. Otherwise, it's purely an admin stuff. Just knowing that metastore will be stored in MySQL, that much should be enough, ideally speaking. So that value will be this in case of the Derby. Okay, so the limitation is multi-user support is not there. Supported. So you will not find this being much used in the real time. So coming to the local metastore, instead of storing this in Derby, you'll store it in MySQL. Or instead of Derby, metadata will be stored either in MySQL or Postgres or any other RDBMS. Okay, but in real time, you will see mostly 90% of the cases MySQL only 10 or 20% of the cases in Postgres. Okay, so this has support for multi-user, no issues. But local metastore means your Hive metastore service and MySQL, they both should be installed. Your MySQL should be installed on the same machine from which you are accessing your Hive shell. Okay, MySQL will be installed on the same machine from where Hive session is being in.
Sure.
Yes, Satish.
Yes, in real time, this one will be the edge node, right?
Real time, even this one will get well ruled out.
Like
yeah, I'm coming there. I will tell you what will be the real time scenario, Satish. Okay. See, remote metastore, here also, you will configure either MySQL or Postgres as your metastore, and it has support for your multi-user. And the advantage with this is remote metastore. You can have your MySQL installed in one single machine, and you can have your Hive client installed in any place, pointing to that MySQL server. So this is the typical configuration that you will find in real time. And in your pseudo clusters, you will find that as a local metastore. In your pseudo clusters, this is the one that is configured. You have both MySQL and your Hive session being invoked from the same machine, and it is pointing to the same 127.0.0.1 as metastore. And your metastore URI, the Thrift metastore service, will be running on the same local machine on 9083. So this means your metastore is local metastore type by looking at this IP address. If you have any other IP address other than local host, that means your metastore is running on a remote machine, and you can have your Hive sessions are able to access that even if they are running on a different machine, then that is called remote metastore. Okay, suppose you have 20 machines on your cluster, and it's not possible to maintain MySQL in each of those 20 machines. Suppose you have 2 or 3 edge nodes. Sometimes it's not just the one edge node we provide to the cluster, so we can give 2 or more edge nodes also. Okay, so those all, you don't need to worry. That's something purely for administrators. Okay, so no matter into which edge node you logged in, you will still be able to access all the data nodes, and you will still be able to access all the cluster resources. So suppose you have 2 edge nodes, and in case as you are thinking like Satish, So if you install both MySQL and Hive client in Edge node, then you need two MySQL installations in both the Edge nodes. So what is Edge node? This is very basic question. No issues. I will reiterate. I think everybody else knows this answer. It's a client machine from which users will be logging into your cluster, and from where your MapReduce jobs will be submitted, from where your pig scripts will be submitted, from where you will be logging into your Hive sessions or Impala sessions or HBase sessions. See, if you have a 20 node cluster, so you will be in a dilemma to which machine you should log in to access your HDFS commands or Hive commands or these things. So instead of allowing the users directly into each of these data nodes, we'll maintain one more machine into which the external user can log in with his own credentials. From that machine, he will be submitting all the requests, instead of allowing external users to directly logging into data nodes. Data nodes are name nodes. Okay. Okay. Now, yeah. So if you install MySQL on the Edge node, for your question, Satish, if you have two Edge nodes, you should have 2 copies of MySQL. And what if they both are not in sync? If one user logged in Edge node 1 and he created a table, that table definition will be created only in MySQL 1. And the another user logged in from Edge node 2, and if he creates a table, then his metadata will be stored in his local MySQL. Now, the user 1 created table can't be visible to user 2, and whatever the table that is created by user 2 will not be visible to user 1. Is that clear? So to solve that scenarios, so we'll maintain MySQL in some other remote machine, and we'll access that remote MySQL server from both the Edge nodes Hive installations by pointing to that metastore using the IP address. Provide that remote machine's IP address here instead of 127.0.0.1. And on that machine, your Hive thrift server, Hive metastore service will be running. Now, in your Edge nodes, you will have your Hive session, Hive shell installed in both the Edge nodes, and you will be pointing to, you will be giving that IP address again here in the javax.java.option.connection URL, and your connection driver name will be MySQL. So in that case, no matter from which Edge node you log in, you will still be able to access all the tables from that MySQL metastore. Okay. Does that make sense? And this is purely for administrators. For as a developer, what you need to keep in mind is that in your real-time clusters, you will be using the remote metastore, and in your pseudo cluster, you are using local metastore. And in case, in any place, if you want to refer to your metastore address, you should refer to, I mean, obviously you'll not have access to even read-only access to conf folders. You should request your administrator. They will be providing the Hive metastore IP address. In case we don't directly use this metastore address in anywhere applications. but we might use sometimes the Hive server address. That anyway we'll discuss during the JDBC client.
Shiva?
Yes, Satish.
Yes, in general, like this Hive site.xml file, is it managed by the admin or
all configurations will be managed by admins.
Okay.
Okay. If I tell it is a property of your Hive or Hadoop, and if I tell if it is a .xml file, it could be site.xml or default.xml, anything related to cluster level configuration. It's purely the job of admin. Okay. So Hive installation is on client machine and any RDBMS is on remote server. Exactly. Okay. So there is nothing in this slide for you to practice. Now I have one complex syntax for tables creation. So far we have seen the basic tables creation syntax. So sample tables creation. So this is fine. Okay. Now I want to take up the Hive file formats with the help of the complex Hive tables creation syntax. So let me Hive commands and functions, table commands. The syntax itself will take another 30 minutes, 30 to 40 minutes. Okay. Okay. Let me explain you this complete syntax thoroughly. So table properties as select statement. Okay. And what else I need is what are the possible values? Stored as row format and stored by class name with Sardi properties. So location and table properties, these are needed. So others are fine. The comment did not exist temporarily. All these are fine. I'm just interested in this portion. This row format delimited by, we already talked about, and row format Saradi, syntax for Saradi classes, and these two things I will put there in the slide. Sequence file, I will put output format. Okay. And table properties, let me take the table properties from here. And all other keywords, you are already aware of it. Okay. So in this syntax, this is my table creation statements. So create, if it is a temporary table, I will use temporary keyword. If it is external, I will use external. Otherwise, if it is a managed table, this table. And if I want to make use of this if not exist class, so if the table is already present, it will not throw error message. If it is if it is already present, it will not throw error message. If it is not present, it will create this table name. And at the time of table name creation, we can specify the DB name as well. So into that database, it will create this table name, DB name dot table name. Now, after specifying the table name, you should provide the column names. Column name and its data type. Optionally, you can provide a comment data type space comment in the column comment in single quotes or so. That way you can repeat n number of columns. So once you are done with specification of all your columns, you can provide the comment at table level. This comment at column level. So this is the complete syntax of your create statement. So if you understood this, you're done with all the various tables that you can deal with in Hive. Okay. So that's why I kept this syntax once again here. So here at column level also you can provide the comments and you can provide at table level as well. Okay. Now we'll be seeing the two more types of tables, which are like partitioned tables and bucketed tables. So we'll see this partition and bucketed tables maybe on Monday, if time permits today. Okay. So for specifying the partition tables, we use this partition by class. Okay. And when you are specifying which column, on which column you should do this partitioning, this syntax. We'll revisit this line once again in partition tables. And for bucketed tables, we'll discuss this line during the bucketed tables. Okay. If it is a skewed tables, that is something which got introduced very recently, and we didn't find much real-time use on this. Let's not worry about this for now, at least for now. Okay. So you'll never see anything skew tables being created in Hive. So if you are curious and if you want to find more information on this, so you refer that article, so you'll find some information. Okay, so I don't want to take this up in the session because instead of giving the clarity on this, people will get confused of it. Okay, and that is for skew. Next, I have row format delimited if my input file is having, as shown in yesterday, the fields are separated by comma and collection items are separated by colon, and map key is separated by hash or any other delimiters that are of your interest. Okay, whatever the delimiters that you have received in your input file. So you can specify all of them using this row format here, delimited and followed by fields terminated and collection items terminated by and map keys terminated by and lines terminated by the 4 extra clauses. Okay. Instead of the delimiters, if you have a file like JSON file, or if you have a file like in another format like ORC or Parquet or something, we should specify here row format SRD. If it is a JSON file, we provide that JSON SRD, and if it is a Parquet file or other files, if it is a different file format, instead of specifying the row format, you manually just specify the stored as file format. That's enough. So in case if the file is not delimited, and if it is a JSON file or any other file schema type, then you can use the appropriate SRDs here. Row format SRD, JSON SRD. Row format SRD, CSV SRD. Row format SRD, Apache common log. The log files. We have seen the load storer functions for log files in Pig, right? Similarly, we have SRDs, common log SRD and common log, combined log SRDs in Hive. So whether to specify delimited or SRD will be decided in row format class. And in stored as, this is the place where we will discuss the file format. Okay. So far, we didn't use this class. This is an optional. If you don't specify this, it is as good as stored as text file. And what are the other file formats that are supported? We'll see in the next slide. Stored by storage handler class also you can specify. This is for your HBase mainly. And the location HDFS path, in case if your data is present in HDFS instead of HBase, then you can specify the location HDFS path for external tables, or it could be managed. Now, additional table properties, you can specify here whether you want to enable the compression on the data, and if you want to enable, what type of compression you want to do. Those things. And create table name and column names as select as followed by a select statement, that is to create a table from the result of a select statement. If the file is fixed width file, the file is fixed width file, okay. So fixed width file without any delimiters. Okay. Without any delimiters in the sense, I think we may find a fixed width related SRD if it is there. Otherwise, we need to use some Pig, like fixed width storage class is there, load storer class. Load that and produce your output with some delimiters. Just load and store with delimiters if you don't find any appropriate SRD in Hive. Okay, but yeah, I never come across this fixed width. We used to have some kind of delimiters.
So Shiva, I have a question here.
Mm-hmm.
I might be asking in advance. I think you might be covering very soon.
Mm-hmm.
So when you give a Saturday, let's say JSON Saturday, for example,
Mm-hmm.
So while we load the file, the actual file will be a JSON file, and that will be converted to a Hive format using the Saturday, right? Whatever the key is it?
It will not be converted. The JSON file will be there as it is.
Yeah, exactly.
While
But
you are querying, it displays you as a table.
so it internally converts into a Hive format, is it?
Yep. I mean, it will not actually convert in the backend also. It displays you as a table. That's it. It shows
Okay.
you as a table at the time of querying itself.
Okay.
So it's like you are viewing an object through a mirror. If you view that special mirror, it will be displayed as a table for you. You will see it as a table. But if you go behind the mirror and see what is there in the backend behind the mirror, it will still be in the JSON.
Right. Okay.
So that mirror is that JSON Saturday.
Okay. So this is the JSON Saturday is a Java class, right? It's a Java program.
Yep, Java classes, those are.
Okay. And how is that? So when we have the Hive, it is already part of Hive itself.
Yep, those are all part of Hive itself. If mostly they will be part of your Hive itself. If not, you need to copy that jar in whichever you find a Saturday. You need to copy that into your Hive lib jars, and then from there onwards it will be available. Or so as I have shown you a command like add jar.
Yeah. I remember that. Yeah.
Using that jar, you need to add it to your shell.
Okay, got it.
Like
Thanks.
the jar and yeah.
Okay, that's good. Yeah.
Now, so out of all these keywords, so these two are parked aside for some time, and this one we will not at all discuss. And row format, so Saturday row format delimited we discussed a bit. Saturday I will park it aside. So this is my main topic: stored as file format and table properties. Okay, so remaining all other stuff you are already aware of. Row format Saturday with Saturday properties, and you'll specify the Saturday class name and all. Saturday, any other properties. Now coming to the stored as, I will spend 10-15 minutes on this. So what are the different file formats and which one to go with in case of Hive and in case of Impala, and in general, what is the best file format in your Hadoop? Okay. So for that, once again,
Hey, Shiva, sorry to interrupt here. What does stored as means? Is it when you
stored as means in which format, whether you want to store it in a text file or in any binary file formats.
I mean, is it while inserting the data?
While inserting the data, yes.
Right. Okay, got it. Okay, cool. Thanks.
Okay. So while inserting the data, I will take this image, put it for your reference. Okay. First of all, why do we need to go for other than text file? The reason is Text files take lots and lots of storage space. That is the first reason. And text files takes relatively a longer time to process your queries or to read and write times. Reading time and writing time to a text file is relatively longer because in HDFS, as I was telling you, data should be in serialized format. That's why when you are reading from a text input format or text file, so we were referring the writable classes. Okay, and while reading from your text file, we were reading it through writables, and once inside the map method or reduce method, we were again converting that into string or integer Java data types to bring them back to original data types. So the point here is that if your data is serialized, it will be faster to transfer across the network, and it will be faster to read if you directly support the binary format. Okay, instead of serializing and deserializing every time from that binary format, so if you choose your file format itself as binary, okay, then it will be, your performance will be improved and your storage capacity will be reduced. Your storage size will get reduced. Now, coming to these file types. So text file we have seen so far, no more discussions on that. The next, coming to the binary file formats, the next one we have is sequence file. And this was one of the popular file format almost 3-4 years back. It was widely being used. So because this was the only binary file format supported in Hadoop that time. So it will be relatively faster than your text files and bit smaller than your text files in size. Okay. Now, in order to create a file now if you are going to create a table in Hive, but underlying files, when you insert the data into Hive table, you don't want that data to be stored in a text file, but want in sequence file. Then only one change that you need to do is create table name T1, C1 string and C2 string, and specify whatever you want, all other parameters, but you specify it as a stored as sequence file. And optionally, you can specify the location also if you want. Location this way. Now, from now onwards, if you insert any records into this, let's run this statement for one file format at least. You will be able to see this, right? Okay. Now I will insert values into this. I'm using insert into statement similar to or MySQL or SQL commands, but whatever the command that I'm using now, it's only for test purposes. Insert into table T2 values, and it's Ramesh, Lakshman. So two words I gave there. See, just for inserting one record, also it is submitting a MapReduce job. And it will create a file in the background. Let's see what will be the file format of that and whether you will be able to see the contents of it or not. Okay, let that continue the execution. Now, so this was the initial binary file format that got introduced. Later, I mean, there were some innovations going on. They came up with RC file. So what is mean by RC file? This is again another binary file. So what is special in this? Record columnar file. Okay. Record columnar file. What does mean by record columnar? Your record became a column and column became a record. Your row became a column and column became a row. Okay. So here, record columnar file formats are three types. Again, all these are binaries only. Record columnar formats. And this is something, even the advanced topic also. Nobody, even after you read 100 blogs, you'll not get all this much of information, the gist of it. Okay. So record columnar formats like RC file and ORC file and parquet. And this text and sequence are just the flat files. I mean, just flat. Your rows will be rows and columns will be columns. So these two are differently processed. Like these two are of flat structure. These two are of like record columnar structure. Now, so what does mean by row being stored as a column? Same concept will be helpful for us in H-based topics as well. Now, let's say I have three columns: ID, and name, and age. Okay. So I have ID 100, name as Ramesh, and age as 32. Okay. So next I have Lakshman, age as 30. Okay. Next I have one more ID, 102, Akhila, 28. Okay. So if I have these three records, if you store it in sequence file or text file format, this will be one record. This will be in one line, and this will be another line, and this will be another line. Now, if you store it in record columnar format, this will be like 100, 101, and 102 as one record. Ramesh, Lakshman, Akhila will be one record, and 32, 30, 28 another record. Okay, so you don't need to worry about how will it distinguish how exactly it's ending the value to here. Okay, so in the binary format, it uses some delimiters between these values. You don't need to worry about that. Okay, so it identifies them as till here only. It's the value. It's not 1001 like this. Okay, so don't worry about till that level of internal details. Okay, so it stores like this. So typically, let's take I have, so this is an employee table. Let's assume I have 20 more columns in this, like department ID, department branch, or department description, and employee last name, employee SSN, employee date of birth, employee organization, so and so on. Like that way, you assume you have 20 columns in this. Now, your business requirement is, I need the oldest 10 employees to reward them during some annual function. So if this is your business requirement and you have 1 million records, just take the typical example, okay? So you have 1 million records, and from that you need the top 10 oldest employees, senior most, or I should call, okay, this is negative, senior employees. So to recognize for some other year. Now, in your typical RDBMS fashion, in your typical RDBMS file format or sequence file or text file formats, so for this age column, you will have 1 million values, correct, right? So 32, 30, 28, 29, 35, 40. So that way you will have the values in 1 million records. So you will write a query like this. Your query is also very simple. Max of, or you take it like select employee names, select name from employee, order by age, descending, limit 10. Okay, so this will give the top 10 employee names with and their ages also if you need age. Okay. Now, if you have a file in record in row format, in row as a record, then to calculate, to get all the 1 million values, you need to load all the 1 million records, 1 million rows into memory, and then take this value from each row. I have 20 columns now. Okay, 20 columns are there. But in my output, if you see, I just need only the name and age. So if I categorize this way, 1 million rows are there, 1 million rows into 20 columns. Means how many total fields? 20 million fields. 20 million field values. If you take this as one field value, this as one field value. So for each row, you will have 20 values. And for 1 million rows, you will have 20 million field values. Okay, so if you assume each of these as field value, you will have 20 million field values. And just for this query execution, you still need to load all the 1 million rows, because if you don't read each and every row, you will not know its age and name to compare with. You are left with only one option of loading 20 million field values into your memory. If you store in this structure, so what are the columns you need? Only the age and only this. You will read only these two records into in memory. Reading by record is possible in your IO operations, but not reading by a column in a file. If in your file, just reading one column is not possible in file IO operations, in any disk types or in any file system. Reading by record is possible. If you have a file, just reading the first two records or directly jumping onto a particular record and reading that record is possible. And after reading that particular record, come out of the file is also possible. But that is called horizontal movement is possible, but not the vertical positioning in any file system. Now, if you store in this format here this way, we'll just read this record and this record. Okay. So here names are having 1 million names and ages 1 million ages. Now 1 million ages and 1 million names. How many total field values? Just 2 million fields get loaded into in memory. That's how it gets the performance gain. Here you are loading 20 million field values into memory and processing them and filtering out all the records, all the field values which are not needed. Here, just the 2 million fields getting loaded into memory and one record at a time there. So obviously you will get performance improvement here. And you will be storing in this compressed and binary format and all the values into one place. So here, no matter this, each record will occupy the similar kind of size. And here, so one record might occupy only, so till this level, and this will be of some size, and this will be of less size, and this will be of more size. I mean, from storage point of view also, it does some kind of binary and compression techniques. It reduces the storage capacity as well. Now, I want your pulse, whether you agree that record columnar file formats perform better than your regular file formats. Do you agree? Everybody agrees on that point or not? Any questions on this? Okay, so if you agree on this, yes, I'm good. Now, in this record columnar format, this is the first file format based on this idea which got introduced. Okay, so later, so in the Hadoop community itself, they did lots and lots of improvements, and optimized record columnar format got introduced. So that means inside any internals of this, if there are any drawbacks, they fixed all of them and it became even more optimized. Okay, the concept is same. From the implementation perspective, it's even more optimized. And on the similar note, similar to ORC and RC, we have RK file format. Same like the columnar, the RC and ORC files. And this RK got introduced even more before ORC. Okay, in the sequence, if I need to put it in the sequence that they got introduced in. Yeah. So RC file, Parquet, and ORC. And so this Parquet got introduced by Cloudera, and ORC mainly developed from Hortonworks. And this is by Cloudera. Okay, and so as I was telling you, when Hive performance was not sufficient with the MapReduce engine, so Cloudera was parallelly working on to bring a competitor for Hive using Impala. And Impala is the competitor for Hive, and it uses the file formats as Parquet. So underlying file formats are Parquet. So these two are evolved from Cloudera. And Hortonworks didn't find a complete new software for Hive. It still uses Hive. Instead of submitting a MapReduce job, it was using Tej jobs being submitted, and it used the file format, background file format as ORC. So because of Tej, your speed gets doubled or tripled or 4 times. And because of ORC, your speed gets 10 times faster. Okay, so assuming at least if your Tej makes it double, and if ORC makes it at least 5 to 10 times, or if you take 10 times, overall 20 times performance gets improved. Okay, so what difference between Tej and MR jobs? It's completely a backend framework. The sequence of DAG actions and the processing types. Okay, we don't need, nobody codes in Tej framework. It's just a matter of like Hive dot, if you are using Hortonworks Hadoop, set this property Hive dot execution dot engine equal to Tej. That's it. It will run as a Tej job. If you set it as MR, it will run as MapReduce jobs. Okay. So DAG as in Spark, yes.
Shiva?
Yes, Satish.
Between Parquet and ORC, like which one is the fastest?
I'm coming there. Okay.
Shiva,
let me complete, Anand. I think, see, you guys are more curious, and before, even if I think of telling the same topic, you will stop me in the middle. Okay. Let me complete this topic and give you a pause of 5 minutes. Okay. Then we can discuss your questions. Is it something stopping you right away?
yeah, just quickly, it was related to the file format. Without metadata, how will it read these rows, these columnar rows now?
Question later.
Okay.
Okay. See, metadata will still be there in your metastore. Instead of text file, earlier you were storing your data in text file. Now you store in binary file. How does that differ? Your metadata will still be there in your metastore. What are the columns and the data types?
So the engine will translate that binary to the text.
It will not translate. It will read that binary as it is. That's where it gets the performance improvement. Otherwise, it's an extra burden. It would have even taken more time to read those files. Engine is able to read binary data.
Yeah, so there is no issue about it. Fair enough.
No issue about it. Okay. So from Hortonworks, these were some of the improvements that happened. So same time, Cloudera was parallelly working, and instead of Tej engine, it brought up completely a new competitor for Hive. But of course, this depends on Impala always depends on Hive metastore. We'll discuss that later. But this got introduced, and also it came up with a new file format called Parquet. But if you consider only Parquet and high ORC compare performance differences, your ORC is much faster than Parquet. But your Impala does not support ORC file format because of their own restrictions. Because this got introduced by Cloudera, and if they keep supporting ORC also in Impala, then Parquet will get vanished. So they've made it mandatory that Impala will not support, at least for now, it's not supported. ORC is not supported in Impala. But your Hive supports both ORC and Parquet as well, no matter who released it. Now, inside Hive, if you compare the performances of it, ORC is much better than Parquet if you consider inside your Hive. But if you compare Hive and Impala, Impala is far better than your Hive with any combination. So here, Hive, Tej, ORC, you made 20 times faster. But because of Tej, you got double the speed. But because of your Impala, which is a C++ massive parallel processing technique, so you will get minimum 20 to at least I can say 10 times faster, or even you'll see even on text files you will see 40 to 50 times, around I can say 40 times faster. And if you use Parquet, it will become even around like 50 times or 50 times to 60 times faster. Or at least I can say 50 times faster than your Hive. We'll see all those. I will give you all these as assignments. Okay. So I will ask you to create one table in Hive and the same table, access the same table in Impala and run one query on 500 record table and see the differences, performance differences between them. And real-time cluster that will scalable, like you will see the same factor, projection factor there. Okay. Now here, so you agreed on that record columnar file formats perform better than regular files. And this RC file is slowly becoming obsolete now. Obviously, sequence file also got obsolete now. So no longer people are using sequence files and ORC files, and the only two options left for now is ORC and Parquet. If you are in Cloudera and extensively using Impala, then make one file format across all the tables, that as Parquet. If it is Parquet, you can use both in Hive and Impala also, the same table. If it is ORC, then you can use that table only in Hive, but not in Impala. So there, the integrity issues will arise. So the recommended file format across your cluster, if you are using Cloudera, obviously the Parquet. Even if you have a better option of ORC. Okay, and the performance and storage comparisons between these files. And even this Avro was released next to sequence files, which is based on JSON sequence. I will try to show you this while Twitter data processing, but even this is no longer a good file format. Now, only the standard across the industry are Parquet and ORC. If you are from Hardenworks, ORC is the one standard across all the tables. You always specify stored as ORC. If it is in Impala and Hive, or if it is in Cloudera, you always specify it as stored as Parquet. Forget about all others: sequence file, RC file, Avro file. But text file will still be there. The purpose of text file is for intermediate tables. Okay, so intermediate tables. Anyway, I will tell you that. I'm keeping you on mute, Vasu. Okay, I'm getting some background noise. So this is the comparison between this text file and record columnar files. So if your original data, if you store in text format, if it is taking 585 GB, if you store the same data in RC file, it will take only 505 GB. And if you store it in Parquet file format, it occupies only 221 GB. But whereas if you go for ORC file format, it takes only 131 GB. Okay. So that slide itself tells the which one is better and which one will be faster as well. Even the performance also in the same sequence. ORC runs faster than Parquet in Hive. Okay. So if you choose either Parquet or ORC, and on top of those file formats, again, if you want to enable any compression techniques, let me tell you what are the compression techniques that are available in Hadoop and which one is the better one. So far we discussed about the file formats and we ruled out all other options, and we took only two scenarios, one Parquet and second one ORC. And I hope you got the clarity when to go with which file format. If it is Hortonworks and Hive, if you need it only in Hive, use ORC. If you need it both in Hive and Impala, obviously you are left with no other option of Parquet other than Parquet. Now, coming to the compression techniques.
Hey, Shiva, before you go to the compression, can I ask a question, basic question?
Yep.
All these file formats, in this case ORC or the Parquet, is typically created from the backend process?
Yep. See, at the time of table creation, you specify stored as.
Got it. But then after that, there is some process running, and you
load data into the table that stores that data in that ORC format.
But can I, without actually inserting into table, I can probably create that file format through some other process without loading into the table directly. Is that possible?
That is possible, but we rarely do that. Yes, that is possible. Using PIG, you can generate ORC files, and the same ORC file you can refer in Hive to see it as a table.
But typically, the best practice is to actually insert into a table, right?
Yep.
Thanks. Yeah.
Okay. Now, let me explain you the compression techniques also, and then I will show you one table creation with ORC file format. After that, I will add on some more assignments to you in this. Then we'll wrap up the session. Okay. So I need at least another 15 minutes. So coming to the compression techniques, so you will come across like deflate, gzip and bzip2, bzip and bzip2 both, and snappy lzbo and zlib. I know I hope everybody knows that what is mean by compression and what are the compression techniques. See, something like if I compress a file, I will get options like, if I compress it, I will get options like, in Windows, I get rar and rar5 and zip. And most of you know that rar is more powerful than zip. Zip only compresses, let's say if I have 1 GB file, if I compress using zip, it may come around 900. If you use rar, it will come around 700 or so. So every compression technique has their own pros and cons. Similarly, in Hadoop, we have these many compression techniques. So while you're inserting data into it, at the time of table creation, if you specify what is your compression techniques, like if you are using ORC, orc.compress equal to zlib, or orc.compress equal to snappy, or orc.compress equal to none, then it will not get compressed at all. Okay, so I'm talking only about this table property. And this transactional equal to true and transactional equal to false, they got introduced very recently in Hive 0.14 to support the transactional nature of the Hive. But this is not a success feature. Don't worry about this at all. And the same case with immutable and true or false. So this one we'll discuss once again in HBase integration. And this is a typical comments you can add in table properties. Okay, so now my focus is to specify the compression technique. Now, out of these many compression techniques available, so which one is preferable? If you don't specify compression technique, you can leave it as it is, or you can specify orc.compress equal to none. Now, out of these, again, compression techniques, there are two types, splittable and non-splittable. Okay, so the top three are non-splittable. What does mean by non-splittable? So once you create a deflate dot deflate file, compressed file, or .zlib file, if that .czip file is of 1 GB, if this, after making it as a .czip, you got a 1 GB file. Now this entire 1 GB file, if you are running a Hive select query, in the background, it submits a MapReduce job, right? So since this will not be splittable, this entire 1 GB is treated as one input split. Meaning only one map task runs. So it kills your parallel processing mechanism. Whereas if this file is splittable by block size or something at the time of processing, so when you are storing it, let it be as 1 GB file only. Okay, and while processing that file, your MapReduce should be able to read that as a different input splits. It can split that into different chunks, and it can read that into different map tasks. If it can split into 8 input splits, then 8 map tasks it can run. Okay, and so these bzip2 and snappy and LZO or splittable. Okay. Now again here, so when compared to bzip2 performance of your Snappy, the compression and decompression times also taken into picture. Compression time and decompression time will also be considered into picture. So Snappy will compress decently in a reasonable amount of time, and this is more popular, and I can say these two are more popular. And again, Snappy comes with the default Hadoop installations these days, and it's available and it's introduced by Google. Snappy came from Google's compression techniques only. And LZO is again one third-party compression technique. So in order to use that LZO technique in your cluster, your administrators has to do get the license from the third-party LZOs, and they maintain all that stuff. So because of that reason, LZO is less used when compared to Snappy. So the popular ones, the options you have two, they both serve in terms of storage and in terms of performance almost equal, but because of more licensing and third-party licensing issues, it takes a bit complex to go for this LZO, and that's where so Snappy got so popular. Okay, so now let me show you a combination of these popular techniques. So create table T1 or T1 or let me take one file. Let me query this table. So let's start from T2. I got C1 as Ramesh and C2 as Lakshmi. Got introduced. So the sequence file got created. Okay. Now let me create one ORC file format table. Okay. So use test underscore db. I think so if I want to know which format I created a table, I can use describe format. Let's see. This is text input format, and this is text, and this is ORC. Okay, so I will take the example same. Show create table E. This was my create statement that I used last time. I don't want all this stuff also. Oh, I created some dummy table. That's okay. Okay. So let me create one similar table, as I didn't have meaningful table there. Let me create emp, so id as integer and name as string and age as int. Okay, and role as string. Okay, no other parameters. Stored as ORC. That's it. I'm not giving anything else. Stored as ORC. Yeah, as I was thought of showing you Snappy also. Stored as ORC, and table properties, TBL properties, ORC dot compress equal to Snappy. So table got created now. If I have to insert a record into this, same, insert into values, insert into EMP, values. I can give 100 and name as Ramesh and age as 32 and role as team lead. Okay. So I can do this. Okay, so let this job run. Give me a 20 seconds break. Okay, so it got introduced into 4 columns. Let me select star from EMP. So I got all the 4 values here, right? So what if I have 1000 records to insert? I can't use all insert statements. Okay, I can't use all insert statement. When I had 1000 records all at a time, what I was doing in text file formats, I was using load data in path command. So now, can I use that same load data in path with ORC file format tables? Answer is no. Then how can I load? You can copy from one table to another table. Okay, let me create an EMP table, emp.txt. Let me write some records into this. Where is this? Okay, now this time I will write 101 Lakshman and age 30 and is a senior developer. Okay, and next 102 Akila and age 28 and developer, and 103 Hasita 27 and developer. Okay, and 104 Anand, and age 30, and senior developer. Okay, so I want to load all these records at a time. Now, let me tell you one limitation here. So this load data in path, load data local in path, I want you everybody to pay attention here. This is one of the important statements. Load data in path or optionally directly from local. This statement, this works only for text formatted plain tables. When I meaning plain tables, not partition, not bucketed, anything. And file format should be text format only. If you have any other features, any other extra features, if it is text only, if table file format is text only, but it is either partitioned or bucketed, either this scenario, or if table file format is not text, then this load data in path will not work. I want everyone to pay more attention on this. This load data in path, when you want to bulk load data into table, this load data in path works only for plain text formatted tables. If your table is partitioned or bucketed, even if the file format is text, or if the file format itself is not text at all, then you can't use your load data in path. To load your data that is present in your local or in HDFS directly into your ORC file format table or sequence file format table or RC file format table or Parquet file format table. Now, the workaround here is you maintain a temporary EMP table. Create temporary EMP table with file format EMP, temporary EMP underscore text table with file format as text file, and from that table copy records using insert into statement. Insert into table EMP, select star from EMP underscore txt. So if you copy records from one table to another table using this statement, you will be able to copy your records into partition, bucketed, and sequence ORC Parquet file format tables. If your table is having any of these features, and which is common in real time, you always have to load your data using this option only. That means you need a temporary text-based table. That's why I was telling, like, in all the file formats, the more frequently used in your real time is text file, Parquet, and ORC. Text file will never be obsoleted. Okay, will never get deprecated. That will still be there. Unless until in future releases, if they overcome this workaround and if they provide us the direct solution. Okay,
So sure, any table you have as a Parquet format, for example, will have an equivalent table which is of text type, is it?
That's for temporary purpose. While in case if you need a bulk upload, that time create a temporary table, load your data into that temporary table, from there to load it into your target Parquet table.
Okay.
After loading, you can remove that temporary text table. Otherwise, it will become a redundancy of data, right?
Yeah.
Okay. So now, in order to achieve this loading into my ORC table, can I load that into my ORC table directly? No. Correct? No one is answering. You're getting my points or not? So I'm following that workaround. Create table emp underscore text. Or you make it as a temporary insert. Once I come out of the session, create temporary table emp text. Now, if I use load data, local in path, so provide the path of this emp text file. Oh, sorry, I should have specified row format delimited fields terminated by comma there. Now I should drop that table. That will not work for me. emp underscore.
Sure.
Yes, Satish.
Yes, after creating a table, like you won't be able to change the properties of the table.
What is it?
Alter.
No, after creating the table, won't you be able to change the properties of the table? Like,
table properties? No.
Okay.
You can only rename a table. You can add or drop a column. That is also metadata changes will happen. In the backend files, data will not change. Okay. Row format delimited, fields terminated by comma. Since I have comma separated values there. Row format delimited, fields terminated by comma. Okay. Now load data local in path. This is my emp. Load data local in path into table emp underscore txt. Select star from emp underscore txt. I can see all the 4 records. Now I will insert these records into my target ORC file format. Insert into table, or I can directly give the table name. Insert into emp. Select star from emp underscore txt. It's running the MapReduce job to copy records from this table to that table. So once after it copies the data, we'll see the file formats in the backend and we'll try to see the data there. So with that, I will wrap up the session. Okay, so just a few more minutes. Okay, now if I select a star from emp, I'm able to get the extra 4 records also. This was inserted by insert into values command, and this was inserted by insert into select statement. Insert into using select statement. Now let's see the underlying, where is it these files are being stored. Describe formatted EMP. So the location is this one. User Hive warehouse test underscore db dot db/emp. So let me copy that. See here, you can identify this is a ORC SRD, ORC input format, ORC output. With this ORC here, you should identify this as a ORC file format. Okay, and under table properties, you can see orc.compress equal to snappy. You'll not have any extensions there, but your data will still be compressed. And now, so this is this answers one of your question, Ramesh. Okay, so long back you asked me, right? Team lead 1 2 3. And underscore copy underscore 1. Okay. So if you observe this in the first 5 zeros or 6 zeros underscore 0 file, you have only the Ramesh record. Ramesh, team lead. Of course, this is a ORC file format and compressed way. So you see some text and some all other information. So only the Ramesh record is stored in one file. And this is your bulk loading. Now, this is what I was telling you, that transaction at record level, even though Hive supported this feature now, it's not useful because just for one record, it created a one file. And if you insert one more record, it creates another file. I hope Ramesh, you are there. Okay. Yep. So for every insert statement, you will end up in creating a small file in the table directory, which is again, it's just another regular HDFS file for which name node has to store the file metadata, the blocks, locations, are everything. If you have inserted 1,000 records using this way, you will create 1,000 files, which is a extra burden or overheadache for your name node. Instead of, you could have loaded all the 100 records in one file and just one file got created, which saves burden on your cluster. So that's why this insert into statements, especially in Hive, if it is a pure Hive table, it's not recommended. That is only for test purposes. Okay, so it's not yet full-fledged useful feature. That's why I still say the same statement. Hive is, earlier I was making the statement as Hive does not support transactional operations. Now I rephrased it like Hive is not suitable for transactional operations. not suitable, even if it supports insert. Anyway, delete will not work and update will also not work. You can try that. So the syntax has been given, but they don't work here. So that is one observation. By looking at these files, you should check. The second observation is that in record columnar format, I was showing you this way, right? Ramesh space Ramesh Lakshman and Akila 32, 30, 28 this way, right? So if you see the contents of here, you can see here. So Lakshman got inserted. Ramesh is in previous file. Lakshman, after that Akila, after that Hashita, and after that Anand. And similarly, if you see the roles, developer, senior developer, developer, senior developer, all are stored as together. And okay, so you will not be able to exactly trace this contents of all these things. You can get the gist, I mean, just an idea of what type of records, what are those.
Sure, just to clarify one thing. If there is one large file and if you do one single load, only one file, right? One file in terms of the compressed file, right?
Not just one file. Okay. So that time it will use as the block sizes. If it reaches the block size or
correct.
How many reducers it uses, not even the block size, how many reducers parallelly it runs. So here, if you see in my MapReduce job, your Hive engine picked it up like only one map task it ran. So no, not even one reducer. So one map task, one output file.
Right.
Let's say, so if there are 10 maps ran and 2 reducers after map task, then 2 output files will get created here.
So I see, okay.
That depends on your Hive framework. How many default reducers or how it decides the number of reducers.
Okay.
Siva, each file, will it be replicated on
It's a HDFS file. All your HDFS concepts holds good.
Oh my gosh. So for each insert, it will replicate it multiple times.
Correct.
Wow. So what you're saying is that insert is not a good thing. Just load it from the temp table or load in a bulk.
That is the best practice. Standard.
But so essentially, this is big data, so your volume should be high, right?
Yeah. Exactly.
Cool. Thanks, Shiva.
Yep. Any other questions around these? Today's is more in terms of real-time examples and the topics I talked about, like especially this record columnar clarification. I was not having at least until completion of my 2 years or 3 years of experience, how it stores in the backend, and the same format it stores in HBase also. This concept will come again there as well. So all are the important topics. Today's session is very, very important. And the next session also on Monday, partitions and bucketing all are also very important. Okay, and in our slides, so next topic, table creation, I will not at all take this. Okay, this already we have seen this user table creation from the user records, and create table with ORC we have seen, and create views. This one, unless until you explicitly ask me, I don't even tell this. It's create features, create views is available in Hive. You can create views this way, create view and view name as your select statements. That's it. Similar, typical to your create table as select statement. And drop view, view one, and describe view, you can view this. Okay. So if anybody doesn't know what is view at all, then let me know, I will tell you.
Yeah, Shiva, we don't know like what is view and all.
Oh, okay. Okay. Yeah, then let me give you 2 lines of introduction on that. And let me summarize what all slides I don't need to explain you guys. Okay. I will come back to that view. Okay. Okay. Next, sample data and table creation. Sample table created, show tables, describe posts, go through this, load data using the load data local in path. This slide is done, and loading data into a table. So this is MapReduce job getting executed there.
Sure, this slide is on the same folder. The slide you're showing,
I
right?
will save this slide today.
Okay, thanks.
And querying data using select star from queries, where classes and time limits less than or equal to limit and drop table, and different types of loads, load data in path, load data local in path, and this one pointing to the external location. If your data is already present in some HDFS location, so create external table, specify the column names, and stored as text file or whatever. And if it is already in text file format or in other file format, so provide that file format and specify the location. It points to that. Just point to an existing location when creating a table. Utilize an existing location. Okay. And if schema is violated, we have already seen that it displays as null. Okay. So here I have all these 3 records as big integers. This is string. Now that in that second record, this being displayed as null because I declared this 4th column as big integer. Okay. So this one we already talked about. So this one I will take it up on Monday directly, and partitioning and bucketing. So on Tuesday, UDFs, JDBC client, and SerDes, and the B-line and performance tuning. So with Tuesday's class, I want to wrap up Hive. So this is my target, at least like almost more than 10 hours, even though we say it 5 days. So almost like every day ending up extra 20 minutes, 30 minutes. So almost like you will get around 12 to 13 hours of time on Hive itself. Okay. So this is the plan for next. Now, in these slides, the only question that people are having, what is view? Let's say you have a 1 million record table, Akila. Okay. So this just give me quick 2 minutes. So can you repeat once about temp file? Or did you ask this question or you got this answer already, Akila? Regarding the temp file, you raised a question.
Yeah, Shiva, I've asked, but I'll see in the recording. No problem.
Did you get it or not?
No, I didn't understand. Let me check in the recording once again. If I get, I'll proceed with that. If not, I'll ask you.
Okay, no issues. So coming to the views, so let's say if you have a 10 million records, okay, 10 million records in a table, and this table contains data for all different states, New York State and Virginia and Alaska. I mean, what I don't know this complete state names. So many states data is there in that for US. Okay, and you are a user from New York, and from New York, you will have only 1 million records. So I have table with all 10 million and all 10 states data with me. But if you are a New York user and I don't want to expose all the data to you, then what I can do is I will not tell which table it is. I will create a view. This is more in terms of like SQL concept, like, okay. So create a view V1 as select star from users table where state equal to New York. This is as good as only your view V1 is like a table with just these 1 million records. But this is not a physical table. It's still, whenever you refer select star from V1 in the underlying backend scenes, this submits this query and it gets all your New York records. Now, I can give you access only to V1, or I will expose only V1 to you. This is like a logical grouping of the records into different tables. This is V1 is one table now with all records.
Yeah, got it.
Okay.
Yeah.
So view is snapshot of portion of data. Exactly. View is like a virtual table. All your answers are correct.
But Siva, the view, for the view, does it get written into the definition, the metastore?
Yes, of course. View will also get stored into metastore. Oh, one more thing that I forgot to show you is I didn't show you the metastore contents at all, not even once.
Yeah, I wanted to see. Yeah, you're right.
Okay, metastore contents display. Someone please remind me on Monday. I will show this.
So, but the view will not be physically written to the HDFS.
View will not physically return to HDFS.
It will be just a
data will be there. That's it. Because this is a virtual table, not a physical table.
The metastore, and it'll only go to the metastore.
Yep, that's it.
And see, there was one question from my side. I didn't get that part. You know, you had Hortonworks and you have Hive, but Hive also works on Cloudera, right?
Hive also works on Cloudera. Yes, I mean that. If you want to run your Impala, you need a Hive dependency. Hive should be there. Hive metastore is mandatory for Impala.
Okay. So, but in this case, when you have Taze, you can run ORC and you can also run Parquet.
Yes.
Okay, but for Impala, it's only Parquet. That's the only difference.
Yes. But when you take these combinations in Impala Parquet, it's amazing. It's super fast when compared with Hive, Tej, ORC, whatever the best combination that you can take in Hortonworks.
Oh, I thought ORC is the fastest.
ORC is faster when you take only comparison between Parquet and ORC. But the underlying engine Tej is much faster than, underlying engine Impala is much faster than your Tej. Tej gives you just the double speed.
Oh, when you combine them, it becomes very fast. Okay.
Very faster. See, that's what I was giving you, like, if Tej runs double the speed of your MR, Impala runs 40 times speed of your MR. And ORC adds another 10 times faster, which may come around 20 times faster in overall. Whereas, if you combine Parquet with Impala, it becomes even more faster, around like 50 times faster.
Shiva, I think Impala is also installed on each data nodes, right?
Impala, I will answer these questions in Impala sessions.
Sure.
Architecture questions.
Yeah.
We'll have one complete dedicated session for Impala. Okay.
And Shiva, what is the default compression used?
Default compressions are zlib. It depends on your cluster configuration. So they can specify in the Cloudera manager. So most of the times you observe zzip. Sometimes deflate. Sometimes either deflate or zzip you will find as a default compression technique.
So for your experience, which is the best?
For my experience, Snappy is the best one.
Snappy. Okay. So we have to provide Snappy as exclusively as a...
Yep. As a parameter. This way.
Neetu here. I have a question about the compression techniques.
Yes, Neetu.
Like this zlib non-splittable compression technique. So a split is done by at the Hadoop level to split the file into the blocks. So if we mention it as a non-splittable file, then how will Hadoop be able to make chunks for the data nodes?
Chunks for the data nodes? Yes, very good, interesting question. See, your blocks will still be splittable there. Blocks, when you talk about this non-splittability in terms of processing, your while reading your file, it will read it as just one input split, even though it can be multiple blocks in the behind the scenes. If you enforce blocks there, it might get split into blocks, but while reading it, it reads that by one map task. Otherwise, you will not identify where exactly your record delimiter is ending. This non-splittability, not in terms of HDFS, this is in terms of processing, input splits.
But processing is done by the data nodes. By processing, I assume
Data
it's
nodes. What is in data node? What is the daemon that processes that? Node manager. Node manager means it looks in terms of logical splits, which is meaning input split. After text input format class, it reads that input split and record readers. You remember that?
Yeah, but you also mentioned that this non-splittable is not good because it will kill the parallelism.
Yep.
So that's where I was thinking that.
See, non-splittable means your logical input splits will be only one for that entire file. How much ever big that file is. Okay.
No, I'm not getting it.
See, if you have 1 GB file, what I'm trying to say is it will get processed by only one map task.
Okay.
Because this is not splittable into multiple map tasks in MapReduce.
So one map task means just one data node.
One data node, yes.
And one data node means just one block?
It can read in, it can copy blocks if there are, if it is having underlying blocks 4 or 5 spread across data nodes. From there, it has to copy those blocks to here and it should process here.
Oh, so the file is split into the blocks, but it will process one block and then transfer the data.
Blocks can be many, input splits will be one. That's what I'm saying.
So I'm a little confused here. Will the blocks be brought in?
Don't worry about these non-splittable compression techniques. Okay. So because of these problems only, we don't use this. Thing is, when I say non-splittable, you are taking in terms of HDFS terms. That's why I explicitly used input split. So this input split keyword is for MapReduce framework and block is for HDFS. Unable to locate pom.xml file in the shared location to set up a Maven project. Oh, it's completely out of context. Okay. See, block is in terms of HDFS, Neetu. Okay. Let's say I create a one .zzip file. Okay. Or you try it with copy that 1 GB file you have already in HDFS, right? You did this in MapReduce. Okay. Load that comma separated file into your ORC file or something, and specify the compression technique as gzip or something.
Okay.
Okay. So try to see if it creates one file or how many files. I mean, file can be one or so. So if the file has, and go to your name node web browser, see how many blocks that file is having. Okay. So what I am trying to say is, if it is 1 GB file, it may have more than one block. Blocks can be more. But while processing here as a MapReduce, it can read that entire file as one single unit, one input split only. One map task.
How is it possible? Because this can be across different data nodes.
Because it cannot identify where is your record getting delimited.
I got that part. But see, if it's a 1 GB file, it might be in 3 or 4 data nodes. Will it bring the block in one place, or is it logical only?
I think block can be distributed into multiple places. Okay.
Right.
Now, while reading, it copies all the blocks to the whichever node on which the task started.
Yeah. Okay.
So because of that overheadache only, we'll avoid this compression techniques.
I see. Got it. Okay, that makes sense.
Yep.
Basically, the one data node will be working, and it will process one block and then transfer the rest of the job, process it. So one data node will be overstressed.
Yep. In one data node only, all the blocks will get copied while processing, and it processes all the blocks and that entire file, and then removes that copied data from the temporary JVM space.
Okay. Yeah. Got it now.
Yep. Anyway, so since you don't even follow these things, so just have an idea first. Okay. So just have, good to go into in deeper details, but only to extent. Okay. Don't make complex.
It just came to my mind.
Okay.
Just that parallelism word, that was just,
Okay.
Yeah.
No issues. Yep.
This is the question.
Clear?
Thank you, Shiva. Yeah.
Yep. Okay. So now, Ramesh, what's your question? I didn't get this. Others can drop off if you are clear. I think it's something specific, Ramesh. What is this pom.xml file in the state location to set up Maven project? The shared location to set up Maven project. First of all, you need to convert into Maven project, any Java or something. Then only will get that pom.xml file get created. I think he's not there. Okay. Anyway, thank you guys. Bye-bye.